Thank you. All right, go ahead, Emily, and read this question. It's number 27 on the same page. It's page 340. All right? These are definite test questions. And go ahead, Emily, read it out.
Write an equation for a line containing the point and perpendicular to the given line.
Right, so here's the point they give you, 0, 6. And here is the line they give you. Okay, the equation of the line. There's a lot of information there. All right, this is a lot of information. But you have to write a line that's perpendicular to the line that this describes. First of all, they've given you a point, they've given you an equation, they haven't told you anything about slope. What do you think? That sounds a little fishy, doesn't it? Are we going to straighten this out? Shall we go in there, get a warrant, and find out what's going on? Let's bust the door down and get the M. All right? On this question, we're given a point and we're given an equation. The first thing we got to do is find the slope, because the slope in these kind of equations is what we're really after. That's how we need to, to get the slope and then compare it to the other things. Compare it to the parallel line. So M is, what's our slope here? Jonathan? What's our slope?
3x.
3. Okay, slope is never x. It's never got a variable in it. It's just 3. So we've got the slope of this line here. Now, what is the slope? We need to write an equation for a line containing the point and perpendicular to the given line. So what is the slope of the line? I put a little symbol here, the perpendicular line. What is the slope of the perpendicular line?
Negative perpendicular?
Not negative 3, because that's not... See, negative 3 times 3 will give you negative 9. You need something a little bit different, right? Yeah.
Negative 1?
Almost.
4.
It's got to be something, 3 times something, which equals negative 1.
Oh, I got it.
What?
Negative 1/3.
No.
Negative 1/3.
Negative 1/3, that's right. Negative 1/3 is the
wrong.
slope of the perpendicular line. Now think about it. Unfortunately, we're not done yet. There's still another step, because what is this question asking? Taylor, what is this question asking? It's saying it's what? Right?
Write an equation for the line containing the point
And?
and
Perpendicular. Okay, now how do we write an equation? Now we have some information. We have the slope of the perpendicular, and we have a point. So, yeah. So how are we going to write an equation of the line? First of all, when you're asked to write an equation of the line, what equation form do you use? Y equals mx plus b. But in this case, we're looking for the perpendicular slope, right? That little symbol is perpendicular, right? The slope of the perpendicular. If that's confusing, I'll take it out. But basically, I'm looking for the slope of the perpendicular line. Okay? And I know that Connor knows what it is. What I wondered if is Lupe. Do you know? What am I going to put in for the perpendicular slope? And what am I going to put in for b?
Negative 1/3.
Negative 1/3. Good. So we can write y equals negative 1/3 x plus b. We don't know b.
Isn't it 6?
Well, no, actually, yes, it is. 0, 6 is, that's right. Actually, what we normally would do, we wouldn't know what the y-intercept is, but in this case we do. But we wouldn't know. So we put that in for x and y, and that's what we're going to do. So 0 and 6, we put in 0 for x and 6 for y. So 6 equals negative 1/3 times 0 plus b. This wipes out, and 6 equals b, right? So we know what b is, we know what m is, we rewrite it back in, we put negative 1/3 x plus 6, and that's our answer, okay? Now that was pretty cool. That was pretty awesome. I know how awesome you think that was. Because look what we did. We have 0, 6, right? We know that's a point on both lines, okay? We started with this equation. We added 3x to both sides. We got the slope of the original line. And then from that, we were able to figure out what the slope of the perpendicular line is. Now that's the key. That's the bridge. How do we know? From the formula. We know that 3 times something equals negative 1, and that something is negative 1/3. And that's the slope of the perpendicular line. Once we have that, we have bridged on over. We've crossed over the bridge into perpendicular line land. And then we deal with that. We've got y equals mx plus b. We put the slope in for the perpendicular. We get y equals negative 1/3 x plus b. We put in the point 0, 6 that we know is on that line as it was given in the beginning. And we figure it out. 6 equals negative 1/3 times 0 plus b. b equals 6. And we put it back in. Y equals mx plus b. M is negative 1/3 as we previously found. 6 is what we just found. And that's it. That's all she wrote. Unless they ask you to write it in standard form, which you would have to then subtract, then you'd have to add 1/3 x. But anyway, they didn't hear. This is it. Good, done. Good. Thank you very much.
Hey.
We have a question coming in from the audience, the participating audience, the studio audience. Yeah, Alexis, what's your question?
What if, could there ever be a time when a line is perpendicular and parallel?
Good question. Is that, we wouldn't know. Alexis has brought up a really interesting question. Is there ever a time when a line is perpendicular and parallel?
No.
How can two lines be both perpendicular and parallel? That's sort of like saying that, look, you have to make up your mind. Are you a rock climber or a rollerblader? You know what I mean? You can't rollerblade up a sheer rock face. Or you can't rock climb on Santa Monica Pier. I mean, you know,
But on Sunday I could rock climb and on Monday I could rollerblade.
but they're two different lines, man. Two different lines. Okay? After right.